Well, hi, Ryan, and all the kids at Camp KSC. Good morning. Welcome to Mission Control in Houston. My name is Pat Ryan. I'm the public affairs commentator on the Orbit 2 shift today here in the International Space Station Flight Control Room. We just finished up our daily International Space Station update on NASA television, and eager to hear your questions and talk about space and space exploration. With me this morning is Ed Van Cise. He is one of the International Space Station flight directors, and they're the people that run everything that goes on in this room. Ed, tell us a little bit about yourself, your own educational and professional background, how you ended up here.
Sure. Well, it's great to be with all of you guys out there at Camp KSC, and certainly a pleasure to get the chance to talk to you. My background, honestly, most of my life has been involved or interested in space to some degree. It started off when I was really young, and so a lot of my growing up really kind of focused on that. I am from Michigan originally, Bay City, Michigan, out near the Saginaw Bay, if anybody's familiar with that area. But went to grade school, high school there, went to the University of Michigan for college. Aerospace engineering was my degree. When I was at Michigan, I was a cooperative education student, a co-op student here at the Johnson Space Center. I've spent most of my career here in mission operations for the International Space Station. I've actually been certified in a few of the different consoles that are behind me here in the flight control room. I worked my way through the various certifications. I've done a few other things here at Johnson, and eventually, of course, applied to become a flight director and was selected in 2009, and I've been doing it ever since.
Now, you also, in your background, have something in common with the kids at Camp KSC. You were a space camper yourself, right?
I sure was, yeah. I went to space camp in Huntsville, Alabama. I went there twice, and it was certainly one of those experiences, both times really, that really helped me focus and realize that I really wanted to be involved in space. And the second time I went, it really helped me realize that mission operations might be the place for me. But even more important, it exposed me to a lot of the things that I don't normally get exposed to back home or back in the school setting. Just all the opportunities, the gee whiz things, not only just that has to do with space, but just all of the opportunities that might be out there, and gave me a springboard, if you will, to go investigate all the different potential opportunities that are out there.
And it ends up as a flight director. So
that's right.
I think we're ready, Ryan. Let's see what the kids want to know about.
All right, Camp KSC, this is your moment to shine. You can go ahead and ask your questions now.
Hello, my name is Michael. I'm from Melbourne, Florida, and my question is: are you worried about asteroids or space debris hitting the ISS? And what is your procedure if something would happen like that?
Hey, Michael, that's a great question, and we actually do have a fairly good concern about the space debris environment that we're orbiting in. Obviously, you're aware of the fact that there is a lot of debris up there in low Earth orbit, and that's just because we've launched not only the United States, but we launched a lot of, as a planet, launched a lot of things up into space and left a lot of those pieces behind. So we fly in that environment. We're not really so much worried about asteroids because they're so large. They're pretty easy to spot once they get close enough to Earth. Obviously, as a planet, we want to know further in advance that they're coming. But for the space station, anything that's about the size of a softball or larger, we're able to track and get out of the way if we have to. The space station has shielding on it that protects it from getting hit by anything that's smaller than about the size of a BB. So anything that's pebble-sized or smaller, we really don't have too much concern with that either. But it's the things that are between BB size and softball size, that's the area of concern that we have, that we're just not really well protected against, but we can't really track it from the ground either. So for that, we do have procedures in place that the crew can respond to. If we call it a rapid depress, but that just means that there's a hole in the cabin and there's air is going out. So in that event, the crew knows how to take action. We close hatches. We could, if it comes down to it, we can get their Soyuz lifeboats and they can come home. But haven't had to do that yet, and hope we never have to, but we're prepared if it comes to that.
There are a lot of different kinds of debris out there, too. Some natural, some not.
Yeah, absolutely. There's you mentioned asteroids, and we think of the big, gigantic asteroids that are out in the asteroid belt, and maybe not concerned with them, but they interact with each other, and they create their own smaller pieces of debris. So there's the natural debris, if you will, and then, of course, there's a lot of the space junk that gets lost or comes apart in orbit.
Um, my name's Shanna and I'm from Port Orange, Florida. My question is, what has been your most exciting day as a flight director?
Wow, that's a great question. You know, the easiest way to answer it is to say every day is a great day, just because I enjoy so much what I get to do, working with the people in this room, the international partners, the engineers. There are so many people that support this program all around the world, and it's just such a joy to get to work with them. But to be honest, there are a couple that really stand out. Of course, my first day as a flight director, I might say it was most nerve-wracking. There was a bit of a ceremony in the beginning. I announced my call sign, so I'm known as Carbon Flight. There was a lot to do with that. But then, for the first time as in my flight director training, all the management and all the teachers that I had, they all left, and I was on my own to run this amazing spacecraft. So that was certainly a memorable event. Only a week and a half later, I had my first, the vehicle, the space station, welcomed me by having one of its big power supply boxes do a power on reset, we call it. But it turned itself off and then turned back on, and that caused some cautions and warnings, and we woke up the crew. So that was my first big, as flight director, experience with responding to something on the spacecraft, on the space station. Just last week, I helped install the Japanese H2 transfer vehicle on the space station. That was a really neat experience. I was a flight director for STS-131, so that was fun. And a keystone so far for me was last summer. I was the lead flight director for the Increment 28 mission. That was a 4-month span of time last summer. And increment lead flight director means that I was the flight director completely in charge of the space station mission. So not just the current shift, like Pat mentioned, we're on the Orbit 2 shift right now, but it's for the entire mission during that span of time.
Around the clock.
Around the clock, yeah, always getting, not all the time, but getting phone calls, and not only getting calls from this room, but my phone rings when the space station has a telephone, so they've called me too. But that was certainly a very unique experience.
My name is Evan McKenzie from Yongsan, Korea. I was wondering what kind of experiments are currently being ran on the International Space Station.
Well, that's a great question too, Evan. The primary purpose of the space station is to be an orbiting laboratory, not only for the United States, but for all the partners that are involved in it. Russia and Japan and Canada and the European Space Agency. They all have laboratory and research facilities and experiments, and we're doing all sorts of work. So that's a fantastic question. The major areas that we try to study are, as you would guess, we try to study everything that would benefit from not having gravity involved in the research. So a lot of the research has to do with the human body, because the human body actually operates very differently when you take gravity away. We do research with materials. Most of that has to do with liquids and flames, because they interact very differently on orbit than they do here on the ground. And what's really unique about those types of research is when you take gravity away, you can learn a whole lot more about how the fundamental science works, which maybe doesn't sound like it's all that exciting, and to watch some of the science, it doesn't sound like it's all that exciting until you realize what the applications of that are. And all the applications of the science that we're doing on the space station really apply to how we live and what we do here on Earth. For example, some of the liquid science that they're looking at, if you understand how fuel droplets are formed, and it doesn't sound like it's all that useful until you realize that engines work that way. And if you want to understand how a spark plug makes your engine fire, and you want to make it more fuel efficient so that you can help with our global warming and carbon footprints and things like that, then you start to realize that this unique science that we're doing actually has applicability on Earth. Of course, all the medical research that we're doing, part of that is to try to help offset the symptoms that the crew feels. Like their heart gets weaker when they're on orbit if they don't exercise, their bones get weaker, they're exposed to radiation. If we want to send them to Mars, we have to be able to figure out how to make it so that they're not so brittle and frail that they can actually go walk around on Mars. All that applies to things here on Earth. So we're learning how to maybe combat osteoporosis or some of those other ailments that are out there. So we're doing a lot of research on the space station that directly applies to improving life here on Earth.
What is the purpose? What is the purpose of building the International Space Station?
There are so many answers to that question. The primary answer is to do that research that we were just talking about. That is really the fundamental reason that we have the space station, is to do that in-depth research and investigations. And it sounds, the investigations that we have up there they range from very expensive, very high-end, like the alpha magnetic spectrometer was, it's a multi-nation, multi-million dollar, if not billion-dollar investment to go explore the cosmos from our orbiting platform. From the other end of the spectrum, we have just taken delivery of 2 spiders on the space station from the H2 transfer vehicle that just arrived, and those are part of a YouTube science lab that. The whole focus of that is to go learn a little bit about how these spiders interact with microgravity and how they adapt living up there. But it was an experiment that was proposed through YouTube by students, and so another focus is to get the people here on Earth engaged in learning new things about the environment that's up there, and then, like I said before, how that can apply to the people here on Earth. So there's obviously a piece of trying to do more than just having the 6 people on the space station doing research. Obviously, we want to go and send people beyond low Earth orbit. We want to go to the moon or go to an asteroid or go to Mars, and we have to learn how to do that, not only with the people themselves, but also the spacecraft. And since we do have this very nice, large orbiting platform where people can stay for long durations of time, we can learn a lot about the people and the systems that are required to do those even longer missions. So if you're going to send people to Mars for it takes 2 or 3 years, we can get a lot of good practice with that on the space station.
And one of the reasons that we built it was to find out how to build a large thing like that in that environment.
Yeah, you're absolutely right. People talk about doing science on the space station, and I come back often with the fact that we have a space station is a lot of science. The systems that are inside it, keeping those running for 12 plus years now, going on for at least another 10, that's a scientific endeavor. And then putting this space station is a football field long, and it didn't launch that way. We launched individual pieces over the course of at least 10 years, right? Mm-hmm. And doing that and doing all the international cooperation and figuring out how to assemble them in space, that it may not fall under the label of science, but it certainly is an engineering marvel to be able to do that. And that was all through the application of the math and the science and engineering that you learn in school and put it up in space.
My name is Alice from Paramount, California. My question was, what is the most difficult part of your job?
The most difficult part of my job.
And this doesn't count as part of your answer.
Right, talking to public affairs. And no, to be quite honest with you, I love talking to people about what we do and being able to share it. So that's certainly not this part of it. There are a lot of challenges with what we have to do. Just putting 6 people up in space and keeping them up there and keeping them happy, healthy, safe, and keeping them with work to do and having good work up on the space station. Obviously, that takes a lot of work and a lot of challenge. There's also a lot of challenge integrating. Really, when you ask a flight director, what do we do? One of our principal jobs is integration. And what that means is taking something from the program. Mr. Suffredini is our program manager. He'll say, I want, at this particular time, I want this particular thing to happen. And then the engineering community will say, well, you need these boxes, and they need to go be able to do this thing. And then you have operations, and they say, well, in order for it to actually function, we need to have this type of software, and we need to have these sort of controls, and you have safety playing a role, and you have all the international partners playing a role. And the flight directors help bring that all together to make it into a package that we can actually put on board and go execute successfully. Sometimes the difficulty lies in that integration work, being able to pull all the pieces together, especially when you talk about my role as the increment flight director, where it was a 4-month span. Then you're not only trying to get today to be successful and not only this week to be successful, but you want the entire mission over that 4 or 6 month or however long piece of the puzzle to be successful. And I'll be frankly honest with you, another difficult piece is trying to maintain a life balance. If I could, I love what I do so much. I could spend way too many hours here at NASA than I really ought to, because I do have a wife and two great kids at home, and it's very difficult to figure out sometimes how to manage. Not being so absorbed and consumed by this job here that I don't get to spend time with them and with family. So it's a part of living here, and Pat's not in his head because everybody that works here loves it so much that it is a challenge for all of us.
That's right.
Very good. Next.
Hello, my name is Brandon. What is the best part of your job?
Besides talking to you guys.
Well, obvious.
The best part is the reward, the sense of reward, or the feeling of reward that you have to see something that you've worked on for a long time really come to fruition and be successfully completed. An example might be this H-2 transfer vehicle mission. We have been working. I'm the backup lead for that, and David Korth is the lead flight director for that, and I will be the lead for the next one next summer. But that's a project that you work on for at least for a year, and you do all of this planning and the integration that I talked about, and then to see it launch, and then being able to see it successfully be birthed to the space station last week, and next week we'll be moving some pieces of it around to outfit the space station. To see all of that come together and be successful is really rewarding, and that's why we put in all the long hours to see whatever task it is that we're doing actually come to fruition. Being able to give, I call them my guys, but the crew that was on board when I was the increment flight director, being able to watch them do their tasks, but then to give them a handshake and a hug when they get back on the ground, we could all celebrate a job very well done. Certainly makes it worth it.
What are the education and job requirements, as well as what inspired you to do this job?
Well, let me tackle the last question first, because it starts earlier in my life. My particular inspiration, it may sound hard to believe, but actually the Challenger accident, when we lost Challenger and its crew, turned out to be a major inspiration for me. Not so much watching the event on TV, although I was in the 3rd grade when that happened, so I did see it in regular replays. But learning about it afterwards, I was reading a book about it, and it talked about how this engineering, this machine basically, was trying to overcome the forces that were happening to it. And to me, it sparked off an I wonder moment of how could engineers go and design and build a spacecraft or a machine that recognizes what's happening, is trying to pull it apart, and yet it's still trying to get those people safely to Earth, to orbit. And that sparked it for me. After that, I just wanted to go learn more about what this all meant, what the space travel thing was, and it just kept going. I kept looking for different opportunities to learn more, and that's how I ended up going to space camp. I could learn a whole lot there. Had a lot of great inspiration there that really set me on my course. As far as working here at NASA, you really need to have a bachelor's degree. And it's a pretty wide range on what that can be. It needs to be something technical, or I'm just trying to think of people that I know. Some people have engineering degrees, of course, but then I know some math majors and physics and things like that. Basically, anything that's in the science, technology, engineering, or math type of degrees will really help get you on your way. Like I mentioned earlier, I was a cooperative education student, a co-op student, where I got to come spend a couple semesters here. For me, I got to learn what NASA was all about. NASA got to look at me and see if I was maybe worth hiring. Because obviously a key piece is seeing if what you think you want to do when you grow up is something you really want to do. Yeah. And co-oping lets you do that. Once you get working here, you want to really work on your leadership and teamwork and communication skills. As far as getting to be the flight director, it's almost a given that you can learn the various systems, but the true test is how well you can lead and lead a team, communicate with all those different organizations we deal with, and communicate effectively.
And what Ed says is true, particularly for those who work in technical fields. But even people who have degrees in non-technical areas can still work here. There are, I don't have a technical degree. Mine is in journalism. I know people who are English majors who work here because there's all kinds of work that is done as part of the support of the space program.
And it's fun to watch and talk to people that don't necessarily have those engineering degrees. Because as flight controllers, we maybe put ourselves in a little box where we just interact with people with those degrees, and it's fun to meet people that have just the same passion that we do, that have business administration, or they work in procurement, or even on site in the facilities. So really, I think the message we're both trying to tell you is that even if engineering or math is not your thing, but you really want to work with the space program, the opportunities are certainly out there. And what you'll find here at this center, and I'm sure it's true at KSC and any of the other field centers, is that everybody they have such a passion for what we do, and then they just able to take their unique skill set and apply it to something that we do here to help with our various jobs.
Right.
All righty, I couldn't say it even better. My name, this is Ryan with DLN, by the way, but I just got the word that we have 4 minutes left, so I think we have time for one more question, and then you can say anything else you'd like to share with the students and say goodbye.
Hi, my name's Lucy. I'm from Gloucestershire, England. My question is, how many calls do you make to the International Space Station in one day?
That's a good question. Also, you know, in this room we've got one person that normally talks to the crew, and that's called the Capcom. And I asked around the other day actually to try to get a sense of that, and they, on a typical day, like today is a typical day in space, they'll talk to the crew 15 or 20 times. And that's true for here in Houston, but of course there are 5 different control centers around the world that interact with the crew at various times, and so they may also talk to the crew. So if they have payload questions, they'll call Huntsville. If they have questions about the Jackson module, they'll call Japan, etc. So it's not. Go ahead.
And a few minutes ago, while we were doing our program, there were calls from the crew members talking to the control room here in Houston, the control room in Moscow, and the control room outside Tokyo, all at the same time. I think the people in Germany were feeling left out.
Right. On the weekends, the astronauts and cosmonauts actually get what you and I would consider to be a typical weekend. They're only working half a day on Saturday. They'll get an entire Sunday off, and so the flight control room here in Houston, we won't have as many people here either, and the flight director gets to serve as the Capcom. So on those days, I get to actually talk to the crew directly. We don't talk to them very much though on the weekend, as you would expect. Most Sundays we probably don't talk to them at all, and then on Saturday just a few times if they have any questions.
Ryan said we're about out of time. Do you have one space camper with a message for the others?
You know, the only thing I can really tell all you guys is to keep wondering about the things that you learn or the things that you're interested in. Keep pursuing your interests. Keep trying to learn more. And if it brings you here or to NASA, that's great. But what's most important is that you keep pursuing what it is that really is your interest. And I wish you all the very best.
Ed, thanks very much.
Hey, very
Appreciate
welcome. Glad to do
it. Ryan, we'll hand it back to you.
Bye. Bye. Bye.